Welcome back. So today we're talking about the CCNA Day 5, Part 2. Talking about the switch details. So meanwhile, if you have any question, you can ask as well. Hope you can see my screen. So every switch, irrespective of their specific model, the switch will have two set of ports, one with downlink, the other one with uplink. The downlink is generally connected to the edge devices, and the uplink will be connected to the other switches. Like I said before, the access switch and the core switch will be connected via uplink. Or one access switch to another access switch will be connected through uplink. So here in this model, if you look into this switch, this is called Catalyst 3750. There you can see starting from port number 1 until 24, which is the downlink where you can connect all your edge devices. And you can see there are two ports with uplink. This uplink port will be connected to another switch. So let's say we'll give you another example. So within 9000 series, where we are generally quoting with the majority of the customer, 90 to 100. Here you can see that the port start from 1x to 12. So here, if you click this, you can see that the port lights indicator, the bottom is the light indicator. The higher one is the RFID for the Wi-Fi signals. And here you have Bluetooth dongle support. So this has more facilities, and this switch have until 48 downlink ports. So here you can see that the name they mentioned, Catalyst 48 ports, PoE plus. There are PoE and PoE plus. I'll let you know what it is. Plus they mention 4 into 1 gig. So generally, majority of the latest switch will have a minimum 1 gig downlink port. If it's 1 gig is the downlink port, then the uplink must be higher than that. Let's say 10 gig. But here you can see they mention G, which means giga port, 1 gig. You have a 4 uplink port, which is SFP fiber port. If you can see that Catalyst 90 to 100, which has 4 into 1 gig SFP, or 4 into 10 gig SFP. So SFP means 1 gig. SFP plus means 10 gig. Keep in mind, that's the one of the difference within this. Okay. Now I'll take a back side of this picture. Now here you can see that there's a 2 power units, power supply unit, PSU. So generally, when you will be connecting, or when you will be quoting this type of 90 to 100 series switches, keep in mind the power supply unit, you need to add extra within the BOQ, or it will becomes up with the single PSU unit. You need to add extra one more if you need it. Why we extra consideration? Let's say within your, let me share whiteboard. So let's say you have one rack, one rack. Within one rack, you will have 2 PDU. Currently, we can have the intelligent PDU where the PDU by itself will have RJ45 port. We can assign an IP address and you can monitor within the PDU software. And generally, this PDU, let's say this PDU is connected to UPS. Okay, and this PDU is connected to AC power supply, direct power supply from the current. And here you mounted your 9200 Cisco switch or any model of switches. And this switch will have 2 PSU units, power supply units. The first power supply unit you're going to give to the AC PDU. And the second power supply unit you're going to give to the UPS PDU. So the benefit of this 9200 have 2 PSU where 2 are connected, one to the AC and one to the UPS. Let's say if the AC main power goes down, how the 9200 switches will serve with the power. The second PSU will be connected to UPS and the UPS will be inactive when the AC goes down. So this is the idea behind why we always consider 2 PSU in order to get the to be in place the PSU within the switches for the load balancing or the fully power redundant purpose. And if you go to this side, you can again see that 2 Cisco stacking cable at the port. This stacking port again for configure for making them a stack. We'll talk about stack later. Then you can see the backside one is called the console port. The other one is called management port. The latest, every switches will have the management port. So the console port is the RJ45 port for configuring the switches. Hope you understood the 9200 concept. We're talking about to the 9300. Let's see. Here you can see the 9300 switch. So generally, if you look into the old switch model, let's say new share. The old series switches, you can see that 2960. Okay, then you can see 3560 or 3550, or you can see 3750. The older model of the switch. Let's, for example, 2 to 3 years back. The 92 series of switches or 900 series of switches, example 90, let's here in this 29 series of switches, example 2960, will always considered as a layer 2 switch. What do you mean by layer 2 switch? The layer 2 switch is just perform switches, no routing. What's the difference? If you have a different network and if you want them to communicate each other, you need a layer 3 switch to route in between them. Some of the old layer 3 switches start from 3000 series like a 3560, 3550, 3750, or higher series like a 4000, 5000, 6s, all are layer 3. And when you say layer 3, that layer 3 switch will also have a capacity to perform layer 2. Do not think that the layer 3 switch is always perform layer 3. No, it can be also performed as a layer 2. When I say layer 2 switch, it's only for layer 2, which means switching. And the layer 2 switches belongs to, as a layer 2 means data link layer. And the layer 3 means routing or network layer switches. Do not be confused. Pazhe kalathu 2916 എന്ന് പറയുന്ന സ്വിച്ച് മോഡൽ ഉണ്ടായിരുന്നു. അത് സ്വിച്ചിങ്ങിന് വേണ്ടി മാത്രം, ലെയർ 2 പർപ്പസിന് വേണ്ടി മാത്രം, അല്ലെങ്കിൽ ഒരൊറ്റ നെറ്റ്വർക്ക് മാത്രം. ഒന്നിൽ കൂടുതൽ നെറ്റ്വർക്ക് ഉണ്ടെങ്കിൽ ഒന്നിക്ക് different 92 series 29 series switches വെക്കണം. ശേഷം 35 series switches വെച്ചിട്ട് അതിനെ റൗട്ട് ചെയ്യണം. അത് തമ്മിൽ കമ്മ്യൂണിക്കേറ്റ് ചെയ്യണമെങ്കിൽ the replacement of 2960 called 9200 and the replacement of 3750 or 3550 is called 9300. Again, the 9200 series can also perform routing. Okay, so let's see how we can in deep can understand this. Okay, let me show you as an example. You share. Okay, for example, I'm going to this all called data sheet 2960 Cisco switch data 2960 Cisco data sheet. $37.50 Cisco switch data sheet. Okay, here you can see that many features, and let me choose switching. Here you can see that the 2960 switches is related to switching for campus and branch offices. Let me try routing. You cannot see routing within the 2960 switches. Okay, now let me try with 9300, sorry, 3750 switches. So here, and even you can, if you come down, you can see end of tutorial. End of so. Now 9200 Cisco switch, 9300 Cisco switch. Here you can see that 3750 switches on the very higher end. It mentioned that end of support or end of sale starting from 2016. There is no sale of this, and whichever sale after that will be end with end of support. So if you have any 3750 switches, it won't be available as a support. Okay, so this product is no more available in the market as a fresh piece. Now going back to $9200 series switches. Here if I click switching, or you can see features here. So here you can see so here you can see that switching features, advanced switching features. So all it has a switching capacity. Okay, then if you look into the routing, so here I also mentioned that it support IPv4 routing. It is also support IPv6 routing with multicast routing. And if you look into 9300, so the 9200 is just a replacement of 2960, and 9300 is the replacement of 3750 or 3550. So here, if I look, it's getting loaded. Routing. Just getting loaded. Okay. You can even try from your end to check the data sheet. From the features, you can see it support routing as well as switching. So the 9200 is the replacement of 90 here you can see the IPv4 routing, and also it supports switching. So the 9200 and 9300 both are support switching plus routing. Okay. Then what is the difference between them when comparing into the old model of 29 series switches? So if you remember, when we do a network architecture design, I said that we have access layer and we have a core layer, where the core layer will have core switch. Okay, this is the core switch, routing switch. And we have an access layer switch, which is called generally act as a layer 2 to connect my all edge devices. So irrespective of model, when I say access layer switch, it's performed with connected to the edge devices. So the latest series of the model of switches, the 9200 series of switches will be generally used as an access switch to connect the edge devices. And the 9300 or above different model, which are generally used for the core layer of switches, which is for especially for routing. Okay, so now here you can see 9300 series switches. Let's see how I can see. Here you can see that 24 port of switches. Then you can see here UPEO. It's a multi-giga port. The U in the sense, this 24 ports can act as either 1 gig or 2.5 or 5 or 10. It can be support any number of speed. How do we want it to do? When do we configure? We need to define what kind of speed that's required. U in the sense automatically detectable. Like for example, if I'm connecting any devices which support 1 gig to the switch, it automatically transfer 1 gig speed. If I have any device which support 5 gig and connected to this switch will be produced that's required a speed. Okay, and here you can see that NM network module, NM module 4 module, which is 10x 10 gig. There you can see TE. If you remember in the previous slide, you were able to see that G means 1 gig, which is 1000 speed, and this is 10,000 speed. And also it's an SFP module. So 1 to 24 is a 1 gig speed or 10 gig speed or 5 gig speed. But the upper port, which or uplink port, which connected to another switches, is called either from a to the access to access switch or access to distribution switch or server farm switch or core switch, anything. It can be support 10 gig. It's called NM module. And if I look into the rear side, on the back side, here you can see that one power supply, high efficient power supply, which is 1100 speed. And the second power supply is an empty slot, optional, we need to, that's what I said, when you prepare a BOQ or bill of material bond, you need to define what exactly that you need within that switch based on the switch requirement. Consider that you have customers say that I have a UPS, I need an alternate power from every switch. If the main power goes down, my switch need to be alive again. So that you need additional power. So the first power, you're going to connect it to the AC power or to the your main current, and the alternate power, which is optional, that you can connect it to your UPS, to the UPS PDU. Then here you can see that the two power stack cable, which is a stacking power for in order to do a stack. Then again, you can see here console cable. Then also you have a USB SSD additional hard disk to put to keep your operating system, which is called iOS, Internet Operating System, or your data. Now, have to remove the power. You can see have to remove the we have power supply and we have fan. So have to remove the these are the fan. So have to, here you can see that redundant fan. So have to remove the fan. That's the question. You can remove the fan, yes. Now, if you go back, you can see that here as a power supply. Power supply. So have to remove the power supply. Yes, when you purchase the switch or when the items delivered, the power supply, everything is a separate, not in the switch. You need to add extra. I mean, you will have the power supply in a different box, or within the switch box itself, you have a separate power supply. You need to add the power supply into your switch. That's what I meant. Here you can see that how many RAM, how many was the flash, everything that you can define in this. Now, I would like to show you one more switch, which is generally used as Nexus family. Nexus switches came into the market for data center for connect your servers. So I said in the very beginning when I said the network architecture, like you have a 2-tier, 3-tier, 4-tier architecture. When you have a very big servers, the servers will never connect directly to the core switch. They have a separate server farm series of switches. So let's say one of the server farm series switch called 5672. Why I'm specifically talking about 5672 UP, because I have configured the switch many times. If you look into this switch, you can see a different set of all are fiber, but you can see a different set of 3 colors. No color, then the orange, some have orange, then the yellow color. Let's the orange colors talking about. You have 10 gig port or 1 gig port. When you have a 1 gig port, you need to think that is called SFP. When you have a 10 gig port, you need to think that is called SFP plus. So this port will be act as a 1 gig or 10 gig. Now we're gonna for the orange color. This is called 24 ports up ports. What does that mean? That this port can act as 1 gig, 10 gig. We'll talking about detail about this. And here you can see, this is what I really wanted to explain you. Here you can see the port model. This SFP is small and this SFP is very big. So this SFP port can accommodate up to 40 gig speed. Let's say the first one I said the 1 gig and 10 gig, and the second one is 10 gig, and the last 6 port is called 40 gig. Here you can see that you have 6 port which can act as a 40 gig. That's called QSFP. What is the meaning of QSFP? What is the meaning of Q? Quad. QUART, quad in the sense 4 times of 10 gig. It's called code. So it's called 40 gig. So you have a 40 gig speed. Why do I need a 40 gig? This is to connect it to the core switch or to another switch. It's a simple theory. When you have your downlink 10 gig, your uplink must be higher speed, either 10 gig or higher speed. Here my the downlink speed are up to 10 gig, so that my uplink would be higher speed, which is called 40 gig. And this 40 gig port gonna be connected to DAC cable. Have you heard about DAC cable? DAC, direct attach cable, which is higher speed and the direct cable connected between switch to switch. Let's say the DAC cable. You can see this port SFP plus DAC cable. You can see this module, which is somehow, let's say, Cisco. Yeah. This is look like fiber cable, but the cable and the connector comes together. It's a 3 meter DAC cable. There's a different company cable, by the way. Okay, so this cable is used to connect between switch to switch with a direct attachable. So let us see on the back side of this cable, rear view. Now here you can see that one power supply here and the one power supply on the other side, and the fan, redundant airflow. Then here also you can see here you can see the management and the console port. Hope you understand the limited knowledge about the how the switch look like. And here I can show you some one more switches. This is the switch, like 4005. Yeah. This is called 4000. Four, 5. Yeah, it's 6 series switches. The switch is called as chassis based switch, where the required port that you can add by manually. If you look into the front side of the switch, you can see this is a slot. You have a slot starting from one slot. This is the stacking cable. Then even you can see 1, 2, 3, 4, 5, 6 until you can see for the 13 model of switches. And if you come down the 13 model, 13 slot, you can see start from port number 1 until I think port number 48, copper cable. It supports maximum 1000 speed of PoE ports. Then you can see on the higher end, there is a fiber ports, which is called SFP fiber port. And again, you can have higher end, like mode 11 will have the copper port. Why do I need this switch? If I have my customer says that I need a 100 or 200 X devices, like for example, I have a 180 camera to be connected in a single rack. So I cannot, even for a normal switch may have a 48 or 96 ports. So by going through this modular switches, I can add required number. Let's say the 13 module, I have a 48 ports. If I add like a 5 or 6 module with the 48 ports of copper cable or fiber cable as per my requirement, I can consume some have 200 to 300 ports. And here also you have seen the console port for configuring the switches. Okay, so by looking into this, what you need to understand, there are different variety of the switches available in the market. If you look into the backside, you can see the Cisco 65. This switches is generally used for the distribution layer, where you can connect a multiple rack. Example as in Sidra Hospital or any HMC will have kind of switches. Okay, so so by going back to our design, yeah, here we're going back to the switches. So what I said, we need a switch to connect here. If you look into the bottom, like there's a network devices and there is a switch on the bottom. You can see the variety of switches. For example, you can see 2960, 24 ports, and even you can see 3560, and you can see the symbol of the switch is different. 3560 is a layer 3 and 2960 is a layer 2. And if I click the switch, you can see on the front end of the switch, let's say, you can see that port number 1 until port number 24 is the copper port, the downlink port, and we have 2 more, the uplink port. Now I'll take another switch. You can see 3560 switch, which is a multi-layer switch, includes switching and routing. If I click that switch, you can see it's a control port, and you can even see that there's a 1 to 24 ports is downlink, and you have 2 ports in uplink. Let me see if you have any other switch within the series of model. You can see 3650. 3650 is another model within the layer 3. And the difference within this layer 3 switch, we can see that the power supply is not added. If for example, I need to turn on, there is a button for turn on. Zoom in. The switch doesn't have power button. Here you can see the power supply. You need to add power supply. Let's, for example, 1 power, 1 second power. Okay, power supply. Let's, for example, if I click CLI, it's turning on. Okay, so configuration we can look later. Now I have, so I'll keep the router on the corner. Let's say, for example, I have a PC1, I have a PC2, I have a PC3. This PC, I need to connect one of the switch in simple. Okay, so as I said in the very beginning, PC2 switch is a straight cable. If you go down on the cable side, you can see it's defined cross and straight. You connect the straight cable, PC1 from the Ethernet port. And if you click to the switch, you can see there are 24 ports and 2 gigaport. The 1 to 24 is a fast Ethernet, which is 100 MB. Therefore, my uplink is 1000. If my downlink is 1000, my uplink must be 10,000. So I'm going to connect to port number 1. Then I'll connect to the port number 2. You can connect to any port, by the way. By default, every switch, either managed or unmanaged switch, will act as a single network by default. And you can see they're going to take some more time. It's an orange color. It will take green in order to become up and running. It takes 50 seconds. The port number 1, port number 2, and port number 3. You connected 3 ports. So it become green now. So it will take some more time to become green, and then this also will take some more times to become green. The time which take the moment you connect a cable to the switch until to the green, it takes 50 seconds time. Now I have a 3 system connected to my switch. So let me ping from my PC1 before I couldn't ping to PC3. Now I'm in PC1. Let's say this is PC2 because I given IP2 to the PC2, and this is PC3. Now I'm able to connect each other. There are little more theory to understand how the switch works. When you connect it to the PC to the switch, how the PC will work to understand the switching portfolio. The switch, the lab is very easy and is very interested to perform the lab as well. But you need to understand the basic theory about when a PC connected to a switch, how a PC works. Or when a PC sends traffic data to PC2, is there any functionality from the switch to perform the PC1 to PC2? Yes. There is a sum which we need to understand. So the next homework for the next class, people who are not given homework, that need to give a homework and need to create a Cisco login. And I have shared the vTransfer file with the packet traces 7.x. You need to install and log in and add PC to the switch, assign an IP, give a different IP. Like for example, PC1 give a class A, PC2 give a class B, and try to reach each other and tell me what is the result. Or within these two PC, assign PC1 class A one network and PC2 class A different network or the same network. Add more computer and do the practical and see where you are getting an error. Then come up with the PC1, PC2 can communicate when they are in the same network. They are not communicating each other when they are in the different network. The way you need to give some exercise to me. Meanwhile, I'll share you some lab. Okay. Any doubt? When we starting to perform the lab, it's quite easy. And as much as you do more lab, you will be more perfect. Okay. And we have one of the interesting topic called subnetting to be learned. So hope you have understood the session today. Thank you for the session and thank you for the time with us. Hope you understood. So this session was CML InfoTech CCNA Day 5 Part 2. Thank you. Have a good time.